Well, greetings, Mr. Kolazar's class. We're going to look at our acid dissociation constant known as our Ka values. And we're going to look at relating the strength of the acid or the base to the dissociation constants. So to begin with, weak acids will produce equilibrium, meaning we can have a reaction arrow going both directions with equilibrium. Our acid ionization constant, Ka's, is that KeQ, but now for acids. So we've seen those equilibrium constants before. So establishing equilibrium, we're going to look at the concentration of the products over the concentration of reactants is going to equal that Ka value. So we're switching it for A for acids. So products or reactants on this side, products on the other, and we're going to look at the concentration of the products times or multiplied together divided by the concentration of the reactants. Now notice what we see is that we have material after when we establish equilibrium. We've got some of the reactant and some of the product for weak acids. Now strong acids do not have Ka's. So a strong acid, example of this would be if we were to look at, an example would be if we had HCl is going to go completely to H plus and Cl minus. So the reason it doesn't have a Ka value is that there is no reactant afterwards. So they're either too big, infinite, or undefined, so we don't have an example or we don't have a Ka for strong acids. So now our weak acids do have a Ka value. So the idea here is that we're going to look at Ka values. They have our equilibrium reactants and products are both there. So with the weak acid, we've got hydrocyanidic acid. Water, we're going to end up producing a cyanide ion and H3O positive, or H plus would be the same idea there. So our expression Ka is going to be the concentration of the products over the concentration of the reactants. So our products, concentration of the cyanide ion, concentration of the H3O positive ion, all over the concentration of HCN, and we're going to write for just a second H2O. Now, key is we're not going to include water because it's a liquid. So we're going to take water out of our products part or our reactants part for our KeQ. So weak acids do have Ka values. Now the more acid that ionizes, the stronger it is. So the more H plus we have, the stronger the acid is. When we compare weak acids, the stronger ones have larger Ka values compared to the weaker ones. They're still weak overall, but they're a little bit stronger. It'd be like having a little guy playing on the big guy's football team. They might be strong compared to the rest of the elementary little guys, but compared to the varsity football team, they're really weak acids. Now remember, KeQ, the larger the value is, the more that products are favored. And for this, we're going to have the Ka for acids and Kb for bases. The larger it is, the more we favor producing the products, in this case the HA. If you were to look at the table here, I'll let you finish this. We'll start out just the beginning, looking at the numbers, strength 1 through 5. The numbers associated here, the largest number is going to be the strongest acid. So which one's the strongest? If we were to look at these numbers, 10 to the negative fourth is the largest small number, so it's going to be our strongest acid. You can finish the table going from strongest to weakest and finish the chemical formulas and the acid names.